is another lecture under mechanics, and by brought to you by Ripple's Lectures channel. So our video today, we are going to do more examples. It's more of calculation under properties of fluid. More examples because we did the theory comprehensively. So I'm going to do now what? Part of the questions. So number one is saying a plate which is 0.025 millimeters distant from a fixed plate moves at this velocity and acquires a force of this value here to maintain its speed. Determine the viscosity, which is mu, between the plates. So they're asking that. You can do the number. Let's analyze it together. So remember, today is our last video under properties of fluid. We are going to just give a seal for properties of fluid using these calculations. So the first question is saying a plate, this distance here, this distance is like y. If you remember our illustration, we drew two plates, this plate here and then what? The other plate. So the plates are distant. If you remember very well our theory, it was y, which is 0.025 millimeters to 10 power minus 3. That is in meters. That's our y. Then from a fixed plate, so this plate is not moving, it's fixed. That means, since fixed, that means our velocity here is what? 0. So you are using 0 for this, which is meters per second. Fixed plate. This plate is moving, that means our velocity v, for this plate here, v, velocity, is going to be equals to 60 centimeters per second, which is the same as 60 times 10 power minus 3 to minus 2, because it is the change from centimeters to meters per second. This is our velocity, this is our y, the plate is fixed, this one is moving. Now, that's it. Then what next? They have given us a force. Now, this force you can analyze very well. You see that this is the unit of what? Shear stress. Because it's saying shear stress tau is same as force over area. So if you see force is in what? Newton. The area is in what? Millimeters squared. So if you change this unit, you find that it will become meters per second squared. So indirectly, this value here is what? The value of shear stress. Because you see from the unit is Newton per meters squared. Follow very well. So that means our tau is given to be equals to 2 newtons per meter squared. So they've given us y, they've given us this, so they want us to get mu. That's our dynamic viscosity. So what is mu? That's what they're asking. So they're asking to get mu. You can say our mu, we don't know. Our mu, we don't know. So we want to get mu, but if you see mu, this shear stress tau, then the y. That means it's like that asking to use the Newton's law of viscosity, or which is say using Newton's law of viscosity, tau, shear stress is same as mu du dy. You get? That's our Newton's law of viscosity. So we are using Newton's law of viscosity, which is mu du dy. So what is mu? Mu we don't know. What is tau, which is shear stress? Shear stress tau, let me put it as shear stress. Shear stress tau is 2. So you can substitute, say here is 2. The same as mu we don't know. It's what we're looking for. Mu into bracket du is the change in velocity. It's the change in velocity. So which the change in velocity is going to be the bigger velocity minus what? A smaller velocity. So the bigger velocity is the v minus u. So what is v? V is this one here. So it's going to be 60 times 10 power minus 2 minus 0. We get that's change in velocity. Then we're also getting what? Du, the y. The y is changing the y distance. Here since it's fixed, that means our x is what? 0. Our x here is y, which is what? Which is this value here. So we find that we subtract here, so it's going to be 0.025 times 10 power minus 3 minus 0. So you get. So I'm subtracting because that's change. So if you compute them very well, you know you can compute for calculators and multiply here. You find that our dynamic viscosity mu, you can say our dynamic viscosity, you get, which is mu, is going to be equals to, you can now substitute. I can leave it for you because you can just divide this one here and multiply by this and get this. So that's our answer. So thank you very much for that number. I hope you understood very well. If you understood, you have some comments, you can comment in the comment box below. So let's answer number 2. Number 2 is saying, question 2. What is question 2 saying? is saying the velocity distribution for a flow over a flat plate is given by that. So velocity distribution U is velocity is 3 over 4 y minus that one there is given, where U is the velocity and y is the distance between the plates. So determine the shear stress at y. Determine tau shear stress at y equals to y is 0.15 meters. So they want us to get shear stress. We get shear stress at that value. So you find that it is simple because they are talking about velocity, shear stress, and U and y. Still we're using the Newton's law of viscosity because we have U, y, and that. So using the Newton's law of viscosity, they're not very simple, they're not very hard, they're very simple, you can follow it very well. So using Newton's law of viscosity, let me go slow. Our tau is equals to mu du dy. That's an Newton's law of viscosity. So what is tau? We don't know. What is du dy? We don't know. So we can just call it maybe equation maybe what? Equation maybe 1. But mu, I think the constant I've given it is what? 8.5 divided by 10. So du dy we can get by differentiate this equation here. So you can say but u the same as 3 over 4 y minus y squared. So when you differentiate this formula here, this equation here, you can get this. So what is du dy? So du dy is going to be equals to 3 over 4. If you differentiate, lower the power reduce the power by 1 and lower it. So it's going to be minus, this one is going to be 2y if you differentiate. It's going to be equals to, because just take them down and have that. So we shall have that. So, but I say at y equals what? This value. So that means the y is going to be 3 over 4 minus 2 times y. Y is what is given, which is this. So you can start, it's going to be 0.15. That. So that means our du dy is going to be equals to, you can press it from calculator. We can say 3 divided by 4. Then after that is we subtract. We subtract, it's going to be 2 times 0.15, yes, 0.15, yes. So after doing that, you have 9 over 20, just that, 9 over 20, because now maybe to get a unit, you know velocity is in meters per second over this which is that. So we divide this by that, we shall have per second, and the unit is per second. So we carry this and substitute inside here. So that means substituting 1 from equation 1. From a very well, it's not very hard and very simple. So our tau is going to be equals to our mu, which is there, is given the equation is here. It is 8.5 by 10. So it's going to be 8.5 divided by 10 times our du dy is going to be equals to 9 over 20. So you can work out this. When you work out that, please work out it and get this answer here. Yeah, thank you very much. This is it marks the end and the seal of properties of fluid. Thank you for tuning to me. Please share my videos, like them, comment them. Please, I want you to subscribe and you encourage us to continue. Or you comment to tell us what went wrong, what went right. Thank you very much. My name is still remains Odon Jasper, lecturing properties of fluids under fluid mechanics. Thank you very much.